Yes, hello. Is this audible?
Yes, ma'am.
All right. So, good evening, class. In the last class, we had started with Newton's third law. So, third law was completed. Newton's laws are over. One topic was left in there which I wasn't able to complete. That was impulse. Let's study impulse first. See, impulse is what impulse can be best understood with the help of example. When you throw a ball, you are having a bat in your hand and a ball is thrown. For how much duration of second when you strike the ball with the help of bat, is the ball and the bat in contact with each other? How much duration according to you? For a very large duration, for a very short duration, according to you?
Very short.
Very short duration, exactly. When the ball strikes the bat, or you can say, take the example, one example you can take, when ball strikes, when bat strikes a ball. When bat strikes a ball, or you can take one more example. See, if you are fixing a nail, then what do? You strike it with the help of hammer if you have to fix a nail in wall. So what do? Hammer is in contact with the nail for a very, very short duration of time. So another example you can take, when hammer strikes the nail. See, whatever force is generated by the hammer during this time, and whatever force is generated by the bat during this time, or whatever forces are generated between these two, that force is known as impulsive force. Impulsive force, you can say directly, you can use the term impulse as well. This is what? It's simply force that you've studied, but it is that force which acts for a very short duration of time. Force which acts for a very short duration of time. So initially what will happen? This is impulsive force. This is exactly known as impulsive force. Whatever will be the total impact on the force, that we called as impulse. Got it? All the forces that are occurring for a very short, for a few milliseconds, like when a ball hits the bat, or even if you're playing badminton, racket, what happens? The cock strikes on the or strikes the badminton racket for a very, very short duration of seconds. The force that is generated that time, this is known as impulsive force. See, if I draw a graph even between force and between time, what will happen? Initially the force will be zero, then the force will be zero, force will still be zero. See, force will be zero, force will be zero, force will be zero. As soon as the ball came, a force was generated, and then suddenly it became zero. And then it kept on being zero. So this is the time when this is the maximum time. Means now the maximum force has been applied for this duration of second. So this is what type of force? This is a variable force. Well, as you can see, force's value is changing. It's increasing, reached a maximum point, decreased, zero. But this occurred for a very short duration. This duration that I have shown, this is a very short duration that has occurred. Now, impulse, how can you write it now mathematically? This is all what is meant by physically. If you want to write impulse mathematically, see, whatever is the total impact of this impulsive force, that we say is the impulse. So it's what? It is the total impact. It is the total impact of impulsive force. It is the written as the product of, see, this is the formula, product of average force and the time of contact. So if you have to write impulse, this can be written as whatever is the average force multiplied by the time of contact. So time of contact will definitely be less, but it will be considerable time of contact. This delta T, this is the time of contact. This is the time of contact. Now see, formula you will be using is this only, I is equal to F average into T. Now, if you use Newton's second law was what? Average force is dP over dt, or you can say delta P over delta T. Now, delta P is the change in momentum. Delta P is change in momentum, and delta T is the time. So average force, put it in the main equation. In this equation, I is equal to F average. So I is equal to F average. Write F average as delta P by delta T. F average I have written into delta T. What am I getting? Impulse is equal to momentum. So impulse, you can define it exactly as rate, exactly as change in momentum. So one definition is the force that is acting for a short duration of time. Other definition becomes the change in momentum simply. And direction will again be same as that of force. Whatever direction you have studied for force, it will be same. So direction is same as that of force, and SI unit. See, SI unit directly you can write force is SI unit multiplied by times SI unit. What's the SI unit of force? Abdullah? SI unit of force. Yes, Abdullah, what is the SI unit of force? Okay, can you tell the SI unit of time? No idea, Abdullah? Are you there in the class? Yes or no? Abdullah, if you're there in the class, please respond either in the chat box or unmute yourself. Yes, Aisha, forces is Newton, time is seconds, so Newton seconds, because force into time. Momentum SI unit can also be used, kg meter per second square per second, but we prefer this SI unit. So we do the questions, just note. Okay, Abdullah. So I hope it's clear now. Forces SI unit is Newton, times is second. So since it is force into time, we write it as Newton into second. All right, note down this, then two numericals we'll do on impulse. Impulse, because questions on impulse come in the exam. That's why let's practice some questions. See, class, impulse is an easy topic, but it is very important from your examination point of view as well. So 2 questions minimum at least we'll practice from this. So there's a wall and a ball of mass 5 kg strikes the wall with the speed of 10 meter per second. All right. It rebounds with the same speed. Okay, this ball comes, then it will rebound with the same speed, 10 meter per second and 5 kg. All right. Calculate the impulse imparted to the ball. Impulse that is imparted to the ball. See, here what will happen? Once you have strike the ball is moving towards the right hand side, and when the ball is rebounding because of this wall, even if you normally also throw a ball gets rebounded and bounces back to you. Now here what will happen? When after the rebounding has occurred, when the ball is moving away, the direction of velocity has changed because the direction of motion of the ball has changed. Earlier this was moving towards the right, now this is moving towards the left. So velocity, we have to consider the sign convention. You cannot consider, without considering the sign convention, you cannot solve this question because velocity is a vector quantity and it involves your sign convention. So let's choose this direction from left to right as positive. You can choose any of the directions, and this let's choose it as negative. Now, as discussed already, impulse is what? Impulse is basically the change in momentum. Means final momentum minus initial momentum. Agreed? This part we have to calculate. Wherever you're not able to understand, just let me know. Aram, did you note all the points? Aram?
No, ma'am.
Okay, after the class, just let me know. You can at least take the screenshot or just remind me once. Okay. So final momentum minus initial momentum. Now see, when the ball is striking it, let's find out the first momentum. It's what? Mass into velocity. Now the velocity will be positive because the ball is going towards the right. So that becomes 5 into 10, that is 50 kg meter per second. P2 is mass into velocity. This velocity is negative velocity because of the sign convention. So that makes it minus 50 kg meter per second. Now put it in I. I is what? I is P2. P2 is minus 50. Minus, then P1. P1 is 50. So that gives you minus 100 kg meter per second. Also, you can write the SI unit or you can write it as Newton seconds as well. Second part says what? Second part of the question says time of contact is given, average force is asked. See in the second part, I is equal to F average into delta T formula will be used, not just a change in momentum. Impulse is minus 100, average force is unknown, time of contact is given as 0.2. So how will you calculate F average? F average will simply I divided by delta T minus 100 divided by 0.2, that becomes 500. Minus 500. Fine, now see, when you're writing the average force, now you can put modulus over here because direction of force is not required over here. So you can write the modulus of impulse so that you can get the modulus of force. So you can directly write it as 500. All right. So this is your answer. Note this question. One more question we'll do. Any doubts in this? Let me know. Try this question first. Take five minutes, and after 5 minutes, we'll discuss. All those will get their answers. Submit in the chat column. See, class, here velocity is like this, and velocity is here. It's like this. Means it is oblique and making an angle theta. So what you'll do? You'll resolve the components. Just resolve into xy plane. Resolve it into xy plane wherever you find it suitable. Fine. In xy plane, resolve this. And get the impulse along x-axis separately, get the impulse along y-axis separately. Like this. So resolve it. Then see what's your net impulse. Let's discuss it now. Did you try at least once, all of you? Aisha, Aram, Abdullah. I hope you've at least tried it, then only you'll be able to understand. See, ball is coming. I have to resolve this in these planes. So if this angle is theta, so this angle will also be theta, alternate angles. If this angle is theta, here we are having this angle as theta. Okay, leave y-axis right now. Just focus on this. First, let us resolve this. This is the velocity is v. So this becomes v cos theta and this becomes v sine theta. Fine. This is vx. This is vy. All right. This is vy. Now, this is theta. So this will also be theta. See. If this angle is theta, so according to corresponding angles, this angle will also be theta. Here it was because of alternate angles. Here this is because of corresponding angles. So this becomes v cos theta and this becomes v sine theta. Now see, again we have to choose one sign convention. Let's take one thing. Let's do upwards. Let's take it as positive. So downwards will become negative. And regarding left and right, let's take right as positive. So right will become positive and left becomes negative. Random sign convention I have taken in front of you. Now I am calculating impulse along x-axis. So impulse along x-axis, velocity is this. Velocity is this. V cos theta along right, V cos theta along left. See impulse along x-axis. This is final momentum minus initial momentum, but only with the x-axis components momentum. So x becomes what? This is mass into the second velocity. See, this is your second velocity. This is first velocity. This is the second velocity. And what sign should we write? Since this is pointing towards the left, according to sign convention, this becomes negative. So this becomes m minus v cos theta. Got it? mv minus cos theta. This is momentum, mass into velocity, minus now initial momentum, m into v positive cos theta. So this becomes minus v cos theta minus mv cos theta. That gives minus 2mv cos theta. Now let's talk about y-axis. I hope this is clear. X-axis is clear to all of you. Any doubts, please stop me in between. See, y will be what? This will be P2 minus P1, but which are associated with the y-axis. Look here. This is V sine theta pointing downwards. That means negative. This is V sine theta again pointing downwards, which means negative. So both V sine theta are negatives. This becomes m minus V sine theta minus m into minus V sine theta. See, this becomes minus mv sine theta. This becomes minus, and here you have again minus mv sine theta. We get mv sine theta. Here we get plus mv sine theta. Cancels. Iy is 0. So it means net momentum, net impulse will be what? Impulse net will be simply Ix plus Iy. Since this term is 0, your net impulse is equal to, what did we get? 2mv cos theta. This is your final answer. All right, this is your final answer. Minus 2mv cos theta. Note down the solution. Any doubts you have, ask me. Now we'll move on to Pulley problems. That's the next section. Note down this figures. resolution of velocities and the solution.
Ma'am,
Yes, yes, Aisha.
ma'am, can you explain this question again?
Yes, see, here what has happened? Velocity is coming. The ball is moving, not straight, but inclined with some velocity. So accordingly, this is theta. So I hope the resolution part is clear.
Yes, yes.
Resolution part is clear. Okay, after that, no? See, V cos theta above this V cos theta, 1 you can say. This is pointing towards the right. Right, we have assumed positive. So this V cos theta, which is pointing towards the left, this becomes negative. Now we have what? We have P2 minus P1. It means m into minus v cos theta, because now we are referring to the second velocity that was pointing towards the left. So that's why minus v cos theta, mass into velocity, which we write. And what about the other P1? That is because of the v cos theta, that was first one, because of the ball that was initially coming. What did P1 means? The initial momentum. So minus mv cos theta minus mv cos theta gives you minus 2mv cos theta. First tell me, is it clear till this step, or should I repeat once more?
No, ma'am, it's clear.
It's clear? Okay. Now see, regarding y-axis, know what happens? Both the sine thetas are pointing downwards. Here what had happened when you were referring to cosine's value, both were pointing towards the opposite direction. So in the opposite direction, when you put minus, then again you have minus, that makes it positive. So you ultimately add. That's why we had minus 2mv cos theta. It got added up. Now what is happening? Both the sine thetas are pointing downwards. So both will be having the same sign, negative, minus v cos v sine theta minus v sine theta. So when you multiply minus mv sine theta minus mv sine theta, one of it becomes plus, minus into minus, and that gives you 0. So your resultant impulse is not because of y-axis, it's because of x-axis only. Did you understand this part, why this is 0?
Yes, ma'am.
All right. So I hope this is clear. Any other doubt to anyone? Please let me know. Do it once you complete it. Text me done, because in Pulley problems, at least we can have a foundation today, so that from the next class we can directly skip on to questions. And someone please, among you only, especially Aisha and Aram, since you already had your exam, if any portion is deleted in your syllabus, no, please inform me, because class 11's latest syllabus of this year I have not checked, and I'm not able to receive that. 12th I am able to. Yes, Aram.
Ma'am, I don't think so. Pulley problems are there.
Pulley problems are there, no, in the
No,
syllabus?
they are not there.
They are not there.
We didn't do that.
You didn't do it in school. Just I'll also confirm it once, because if Pulley problem will take a major portion of your time, and I'm also just not sure about this. The syllabus still the first and two those lessons I knew, but from laws of motion till your this completion of first book, I'm not aware of the syllabus. So that's why if it is deleted, so please let me know. Otherwise, why will we waste our time? I see laws of motion is such a huge chapter. And if things are deleted, that is beneficial for you all. Because last year it was added. Last year it was there in syllabus. That's why I just want to confirm. So just both of you confirm among yourselves as well. If you both are sure about this, then we can skip it. And if it is by chance there in your syllabus, after the next topic, we can complete. So just let me know once you write it. Yes, Aram and Aisha, you're right. It's been deleted. Now, see you, class. What we'll do in your work, energy, and power questions from pulley problems have not been deleted. They have deleted the major pulley separate section from your laws of motion, but they have not deleted from your work, energy, and power. So either we can do one thing: we can complete the pulley problem here only, or we can complete it in work, energy, and power. But in work, energy, and power, no, the concept will like the question will be asked to calculate the power, but you will have to ultimately use the pulley constraint if the pulley is present. So that has not been deleted from the numericals of work, energy, and power. So let's do one thing. Let's practice the basics of pulley, how to just solve it, how to draw the free body diagram, and how to get the acceleration, the minimum thing. Let's not go into the details of pulleys, but for your laws of motion, for your upcoming lessons, work, energy, and power, and not only work, energy, and power, even in your rotational dynamics, this pulley constraints has not been deleted in your from a numerical perspective. So we can do one thing. Let's just practice the basics of pulley right now. Then we won't go into the details of those tough questions that we have. Otherwise, what would we have been doing? We would have practiced so many pulley problems with 5 to 6 pulleys connected in different manners. That we won't do. Let's just do the basic pulleys. So that afterwards, no, we do not have to go back into this topic. So similarly, circular motion and friction, all these topics, then we'll cover it. Whatever topics have been deleted and they have no use further, that we will not do. But all the topics that have use in your upcoming chapters, like your especially this pulley mass system, at least let's just practice those. Otherwise, if questions come in your exam and if questions get modified a bit, or if a question is from previous year, let's not face any kind of issue. See, pulley problems now, it's very easy for all of you because we do not have to go into the details. Just the calculation part is easier. That is definitely easier. What you have to understand, how to make the free body diagram. See, a pulley is there. Circular motion has been done in your school. Aisha Iram. Circular motion.
Oh, yes, ma'am.
Circular motion is there. Circular motion will be anyways used in the upcoming lessons as well. So circular motion, friction, all these lessons have certain bases. Let's say a pulley has at one end attached mass M1 and at the other end has mass M2 attached. Now see what will happen. Tension is a force that develops in the wire, in the string. This details about tension you study in the last lesson. When you have no waves you must have seen or heard, waves and oscillation that is present in your last lessons. So there you have this details about strings, speed of string, forces of string, like this. There you have in detail about tension. But right now, just understand the force that acts on the strings, that is known as tension. And tension is directed away from the body. So here what will happen? The direction of tension will be away. Now in a single wire, tension remains the same. Here what happened? A single wire was passed over the pulley. No, pulley was here. Now among this space, the wire was kept in a U-shaped manner. So that's why this is a single wire. So here there will be a tension. Here will also be a tension. Got it? Whenever you have pulley problems, do not forget tension. All right, class, tension will be there. And what will be the direction of tension? Away from the body. Then you have gravitational force, which acts downwards. Gravitational force will always act downwards, no matter what. This we have already studied. Acceleration due to gravity's direction is always towards the ground, that is downwards. Now, force downwards will be what? Acceleration is G, mass here is M1. So that will be M1 into G. Here mass is m2, so mass into acceleration. Acceleration here is acceleration due to gravity. Because there is no machine connected, there is no generator power supply connected to make the masses move. The mass which has the body or the object which has the higher mass moves downwards automatically because of the gravitational pull of Earth. So that concept only we have been using. Now what we have to do. So let's assume also one thing. Let's assume something. Mass 2 is greater than mass 1. Now for drawing the free body diagrams, just understand this part, then I'll end the class. So in the next class, we can start with a different topic. Just focus on M1 right now. Tension was above and M1, G was below. No other force was acting. You just have to figure out what all forces are taking place. Now see, if we assume that mass M2 is greater. So this will go downwards, acceleration will be downwards here. And since this is lighter as compared to M2, this will go up. A, fine. Wherever you're not able to understand, please ask me, I'll repeat it. Because though these terms will not directly come in your exam from this lesson, from the weightage of this lesson, but further it will be used. Now, we are just focusing on M1. What happened to M1? Where is the acceleration going? Acceleration is going upwards. This is known as free body diagram. You have just taken your body out of the system and whatever forces, whatever velocities, whatever accelerations are acting on your system, you draw it separately. Fine? Now see, how to choose the sign convention now. Whatever is the direction of acceleration, that is taken as positive. So all the forces that are acting in the direction of acceleration that are taken as positive, all the forces acting in the opposite direction are taken as negative. So tension is upwards, so tension will be positive. Minus, because M1G is downward, so this will be negative, minus M1G. This is the net force. This is the net force in the system. Got it? T minus M1G. One has to be taken positive, one has to be taken as negative. Which one has to be taken as positive? The upwards one. Right? So T minus M1G. This is equal to mass of the system multiplied by acceleration. How? Mass into acceleration. F is equal to MA. Just tell me, understood this part or not? Aram? Abdullah? Abdullah, what about you? Are you able to understand?
Yes, ma'am.
Yes, Aisha, you asking something?
How did we get T minus M1G?
See, like this. T is their net force we are calculating. So how to write the net force? Two forces are there. We can add it directly also. How to write the net force? The method to solve is whatever is the direction of acceleration, all the forces in that direction become positive and other forces in the opposite direction become negative. So this is towards the acceleration side, upwards. Acceleration is also upwards, so we write it as positive. Since this is downwards, that's why we write it as negative. And then the net acceleration. Got it? How to write the net force? See, I'll show you one more thing. Let's take the example of second, M2. Tension was upwards, M2G was acting downwards. For M2, remember? Yes, Aisha.
What exactly is tension?
Tension, see, tension is basically the force that acts along a string or spring, you can say, or thread, you can say. See, force is same. One physical quantity is their force. Now, when the force is able to rotate an object, we call it as torque. When that force only acts on a very fine string, we call it as tension. So force, phenomena of force and the meaning of force remains the same. Basic, push or a pull, the force that acts in a system. But because of the certain circumstances and other situations, the meaning of force changes. So if you have, the way you will see in your rotation classes, torque is present. Torque is what? Nothing, it's force, but it's the force that rotates an object. Similarly, tension is a force that is occurring. See, if you're pulling, if you are just tying a block with a string, a force will be there on the string as well. Action reaction we have studied. If the string is able to apply force on the block will also apply force on the string. So specifically, instead of writing it as F or something else, we write it as tension. We call it as tension. And property of tension includes that this tension is directed always away from the body. We could have drawn this tension towards the body also, no? Like this we could have drawn. This is the force that is acting. No, it is associated always away from the body. Fine? Now see, this is acceleration's downwards direction. It means downwards is now positive, upwards is negative. So M2G is positive, whereas now tension is negative. So this is what? This is the net force equal to mass of the body into acceleration. This is how you write the equations. Now you have equation 1, you have equation 2. You use these equations to get the value of acceleration, to get the value of tension, to get the value of whatever, you know. You have 2 equations. Now only 2 variables will be left. Whenever you have your questions like this, you solve. This is how you solve your Pulley constraints. From here, you calculate acceleration as well. In the next class, we'll do one thing. We'll just take 1 or 2 examples so that this gets clear. Then we'll move on to the next topic. Quickly note this as well. And just text me done, then you can leave, because your next class will begin and my class will also start.